Welcome to the Calculus A section. In this section we will be discussing derivatives and rates of change. The derivative is representative of the rate of change of a function at a given point, which means the amount of function changed at any given point. This is often referred to as instantaneous rate of change. Recall when we learned the slope of the tangent line. We approached our point of tangency, and the closer and closer we got to the point, the similar and similar the values became, meaning the rate of change was that said value. So now we can rewrite this idea in form of limits. We can say that the slope, m, is equal to the limit as h approaches 0 for the function f of a plus h minus f of a all over h. As you can see, if we plug it in one of our limit methods, we would get a 0 in the denominator. So what we usually do is we utilize the asymptote method, or we can utilize the algebraically isolate x method. Additionally, recall when I stated that x is actually equal to a plus h. And this means that h is equal to x minus a. And that is why we no longer have that in the denominator, because previously when we approximated our point of tangency, or our equation for a tangent line, we said that f of x minus f of a over x minus a is actually equal to our derivative. However, we rewrote this using our h substitution. So let's look at a problem now. We want to find the derivative of x squared minus 6x plus 9. Okay, so we're going to plug this function. This is our f of x. F of x is equal to x squared plus minus 6x plus 9. And we can plug this into our definition of a derivative, and we can get the following. A plus h squared minus 6a plus h plus 9, parenthetical, minus a squared minus 6a plus 9, parenthetical. Okay, so we're going to distribute this negative, and we're going to say that negative plus, there we go, and this is going to be negative. And we're going to expand this and get a squared plus 2ah plus h squared minus 6a minus 6h plus 9 minus a squared plus 6a minus 9. And you can see that we have like terms, and we're going to go ahead and add and subtract. So we can cancel out our a's, we can cancel out our 9's, and that we can cancel out our a's. Okay, and that leaves us with h squared plus 2ah minus 6h, and remember this is all over h. And now that is equal to h plus 2a minus 6. Now we can plug in, since this limit is from h to 0, we can plug it in, and we now get 2a minus 6. And that is our derivative of the function x squared minus 6x plus 9. And if you want, you can substitute this a for x and say that 2x minus 6 is our derivative. Either one should be okay. If you need more help or want to do more problems, the website has a bunch, and I hope that helps.